I'm Sam Abuelsamid, Principal Analyst with Guidehouse Insights, and I'm joined today by a really great panel to talk about smart connected vehicles that anticipate and automate. With me today is Lars Reger, the Chief Technical Officer of NXP Semiconductors, Martin Bornemann, Director of Systems at Aptiv in their Mobility Architecture Group, and James Hodgson, Principal Analyst with ABI Research. Good morning, gentlemen. How are you today?
Hi, Sam.
Great. Doing well, thanks.
All right. Why don't we dive right into the conversation? So starting off, first of all, like each of you to answer this, how do you define connected vehicles, and how has the car transformed to being connected? Lars, you want to go first?
Yeah, the key definition of a connected vehicle is, of course, or basically the biggest change, that the vehicle is not finished at the end of the assembly belt and then is more or less isolated out there on the roads, and after 10 years becomes a pile of salvage and gets dismantled, but that the car basically starts alive when it leaves the factory. And it is connected, it is updated, it is a rolling sensor platform that can bring data back to the other side of the connectivity, so in other words, the cloud. And like so many smart connected devices around us, gets a life cycle in itself. For that, of course, you need to have the right connectivity in place, well, very clear, but you also need to be able to trust your connections, and you have to be able in a safely and secure way to manage the data inside the vehicle, so that it always, of course, does not destroy the life cycle of the car or create issues. Yeah, so that's basically the biggest disruption, biggest change with connected vehicles.
Martin?
Yeah, so it's very important to have a private pipe into each and every car in the world itself, because the difference to what we see today, that a car is a fixed thing you purchase and it stays until we put it into trash, because the new cars will be a living element. It will be updating software, it will have a virtual twin, it will deliver data like Lars already stated. So it's a kind of a living element in this data world, in this digital world. So for me, the connectivity is very important here in order to put new software into the cars, but also to bring new features to the customers after the car has been sold. And that's very, very important. Because it creates a pipe also for revenue after the car has been sold, even if it's in the second or third life, where it's normally, a kind of a cheaper element than somebody buys it in the first row. It can produce revenue. We can update hardware later on because we can always retrofit the software in these cars. It's a very important element for all of us, that the car is not this kind of fixed element after it has been purchased.
James, how do you see the connected vehicle?
Yeah, it's a great question. I think many conversations that you can have will simply define a connected car as any car that has an embedded cellular connection in, or some kind of short-range wireless technology equipped to it. And of course, that's been happening for many, many years now. But very often in a way that's been quite superficial, not really taking advantage of everything that two-way connection with the vehicle it can allow. And it does feel like we're reaching an inflection point now where we don't just have superficial, entertaining of the driver or informing the driver, but rather we take advantage of that connection to, update and maintain software-defined vehicles. Maybe aggregate insights that these, millions of connected sensor-equipped vehicles can offer from roaming around all the roads across the globe. And maybe even moving into mission critical applications like V2X, adding to the safety of the vehicle.
So let's stay with you for a moment, James. How many types of connected devices do we have in the vehicle today? And what types of connectivity? You mentioned a couple of things there, cellular data and V2X, but how many types of connectivity are we using? And how do you expect that to change over the next 5 to 10 years?
Yeah, sure. So yeah, cellular is more or less pretty standard now. We expect that by the end of this year, about 57% of vehicles that ship will have some kind of connectivity in, whether that's cellular or short-range wireless connection to a brought-in cellular connection like the smartphone. and we expect that to grow over time, maybe somewhere around 70% over the next 5 years. And short-range wireless connections like Wi-Fi and Bluetooth have been fairly standard for integrating brought-in devices for a few years now. I think it's fair to say that some of the new experiences that we're expecting over the next few years will be technology-driven. For example, introducing ultra-wideband to enable more secure access for drivers as they approach their vehicles, and maybe also some kind of distance measuring and sensing technology there. But a lot of the change will actually be driven not so much by revolution in all these wireless technologies, but rather by an overhauling of the architecture in the vehicle, the compute architecture inside the vehicle, the connectivity that happens inside the vehicle, so we can make the best use of all these wonderful connectivity technologies that connect to what is happening outside of the vehicle.
Martin, I think that's a good place for you to step in with architecture. As the vehicle electrical and electronic architectures are evolving rapidly now, and we're going from where we were. Where we really are today, where these systems have grown up in sort of a piecemeal manner over the last several decades, as each time we add a new electronically controlled feature, and it's changing. And can you talk a bit about how the EE architecture is changing and how that impacts the connectivity?
Yeah, so first of all, 5G will change our world because of the reliable connection to the outside world. That's something which is very important, that we always have a reliable pipe to the outside. But the inside of the vehicle will change a lot because the cars have been more or less growing into an area where we have about 100 boxes, up to 100 boxes in cars. Even mid-size cars have about 35 to 40 boxes in that one. They're really, really hard to update. And the software interfaces in between the boxes are really critical, because it's in the meantime a really big challenge to develop software in these kind of environments, because the connection in between the boxes are more and more critical. So we see an era now moving into the concentration of compute in a very small number of boxes. So it means we see this a kind of a small brain, big brain approach, that we have one compute node which really takes care of body, connectivity, for energy management, for vehicle motions, all the slow moving world, and then have a bigger compute node. So an analogy to our human brain, the big brain, then for ADAS and UX as separate compute modules, or even as one. So also a strong concentration of compute into a much smaller number of boxes. And underneath the zonal network, because it's also important to have an abstraction of the sensors from the main compute itself. And that will be realized by a zonal controller network, which then concentrates also these big number of boxes into a much smaller number. So we think in the range of 15 to 20 ECUs in the car are more than enough in order to consolidate all this functionality in the car. So that's really a change which is upcoming. The most important change which we are facing here is really the software-defined car. And that's only possible by good software interfaces in between what we call the machines in the cars and the application layer. So here a predefined standardized machine layer in between the machine and the application software, like your Windows PC, like an Android smartphone, is mandatory for the world. So standardization in software interfaces will be key for the next years for us.
Lars, NXP is, I think, currently the largest supplier of semiconductors to the automotive industry globally. You supply to probably, I would say, most of the world's automakers. What sorts of things is NXP doing to help enable this transition? What kind of products do you have that help make this transition, both connectivity and the EE architecture, become a reality?
Well, Sam, thanks. I mean, very honestly, the good thing that I have in front of me is after this merge in 2015 of NXP, old NXP and Freescale, that we have a pretty broad portfolio. So from the sensing of the car, so radar sensors, for example, to actuator electronics, to connectivity electronics. We just bought 1.5 years ago the Marvell Wi-Fi and Bluetooth business, but also to V2X type of connectivity standards. We have it all in our portfolio, and of course what we also have is all sizes of microcontrollers and microprocessors. And what Martin just had pointed to is, of course, you have at the moment the legacy vehicles, let's say 20 boxes, flat CAN network, everything hooked up to a pretty old-fashioned network. Then what you have, domain clustered architectures, because of course already today you don't want to change the software in a window wiper module and have to requalify the ADAS system, right? I mean, you try to firewall that from each other. And of course then what Martin pointed to is now the next step in the architecture, the zonal architectures that are in principle up aggregations of certain domain functionalities into fewer boxes. So all of that requires similar Lego boxes that we have basically in our semiconductor portfolio, and therefore we are very, very close with the tier ones, with the car OEMs in defining now, okay, which software interfaces and which form factors do you see in your next generation vehicles? How do we make sure that we not only bring, let's say, the data pumping functionality in, or the compute functionality, but also the functional safety and the security? Because in the end, you have a connected device. Connected devices are vulnerable to hacking from the outside. I mean, that's exactly the downside of the connectivity. And of course, as you have in principle, very dangerous device that you're building there, you have to make sure that your functional safety is maxed out. So what we are seeing at the moment is very close collaboration between the architects of the tier ones and the OEMs, the software and the hardware providers, into reference designs and into really stepwise evolutions of these platforms. And then NXP is of course pumping the silicon into that game. Yeah.
With this consolidation, does that mean that we're going to start seeing less semiconductor content in the vehicle, or how's that going to change as we consolidate down to fewer boxes?
We are seeing definitely different semiconductor content. So what Martin was pointing to, he said 10 units per car. I mean, these units have, of course, to have a much higher compute power than each of the 100 units as of today. I mean, logical. But then also to the edge of the car, I mean, to your radar systems. I mean, just imagine there is cars that have between 10 and 15 radar systems or camera systems around the vehicle installed. Now, what you have, of course, there, you have these different nodes with different capabilities. A front-facing radar or corner radars or side impact radars, just to stay with that example, will very often now become one-chip radar systems. Very efficient compute nodes, low power nodes, so they don't have the monster compute capability directly built in, but they are of course linking then to a bigger fusion unit. You have zonal architectures already since 15 years in your cars. We call them door controllers, right? Where you have over the different domains, you have your wing mirror control, your window lifters, your car access. You could have radar or ultrasonics in there. You have your sound via Ethernet audio video bridging, synchronous sound for the left and right speakers in the doors. So if you want to take it literally, you have there already, but of course on a much lower performance level, zonal architectures in, and these type of devices will stay, but will grow into these higher compute nodes that Martin was mentioning as well. So you see, it's a pretty flowing continuum of semiconductor applications.
Yeah. So automotive development comes in steps, like Lars already said. So we have seen the domain controllers coming the last years. Now it's time to integrate the zones, but also this is not the final step. It's an evolutionary step. Because next time what we see, also Lars said, we will see kind of raw sensors more and more, and then also a well-layered compute in cars. That the zone controller is really the next big area where we up-integrate compute, but this is the lower level compute. So to unify the sensors on the zone controller already in order to have then really a generalized compute and also generalized compute architecture above that one. So the zone controller for us is a big chance then really to equalize all these different sensors to a common output, to a common behavior, that all the differences which are normally in the sensors from the different manufacturers will be equalized at that point in the zone controller. Also a concentration of compute from the sensors into the zone controller, that we have really generic high-end compute really on the top of that network in order to do the higher level algorithms. So for us, it's a chance with the zone controllers to get a well-layered compute structure in cars, which will provide us a sustainable software architecture where we can move software and not port software. We are losing 20, 25, even 30% of our people in porting and modular releases. This has to stop. We want to get these people back in the tier one and also in the OEM market to do really innovation and not to port old stuff onto new devices.
So does that require going to, you mentioned a layered approach, would that be abstracting the software away from the hardware so that it's the software, the application software is agnostic to the hardware?
Definitely. So it's more, like I said before, it's a machine layer. To means it's the hardware plus a good middleware, a standardized middleware, like you have it in Android and Windows 10 and other more or less good platforms, that you don't care, that you develop on the standardized environment with standard inputs and outputs, which will be provided by the whole car, and that you have the higher level compute algorithms really running on the standardized environment, where you can easily exchange later on the hardware. So my dream is that we can qualify new hardware, and Lars will help a lot of, I think, to Lars to have new hardware in cars in 18 months time frame, not in 3 years, 4 years time frame. We have to be faster, much faster than we are today.
Yes, and of course, what you also will see is, I mean, new functions that we don't think of with self-driving robots as of today. I mean, you all know as a human being, you have reflexes. So if you stumble over a stone, your spine tells you, Sam, straighten your leg before you consciously have started any motion, because you would be face down on the ground if that would be a conscious process. Now, these type of reflexes, we can of course also build into cars. Just imagine, camera, radar and LiDAR all are shouting obstacle, obstacle and obstacle. In this case, you don't need to have the high performance unit in the latest AI understanding what is the obstacle in front of me, what do I need to do. But there you have to have a very fast standardized short circuit saying, okay, 3 times obstacle, do an emergency brake. Like your reflex in your spine, and only after that try to understand what you have in front of you. But these type of, let's say, signal change, this chains, this cascading, all of that handling. I mean, if you try to do this on today's spaghetti wiring harness where it's not clear how the sensor landscape is looking like and is different from car to car, completely impossible, because you never have a chance to qualify these type of data flows, setups, time-sensitive networking, and so on and so on. We have the ingredients, we don't have the system yet, and that is going to come and has to be modularized. Otherwise, it's undevelopable.
So well-layered compute means also here, like Lars said, reflexes. So like a pinch protection in Windows, you don't want to have a long signal chain there. Where a high-level compute really decides about the life of your fingers if you put them into the windshield or into the side windows itself. So the right kind of compute at the right layer in the compute system, that's important. So reflexes where we need them, but the concentration of compute in higher layers in order to have this complex behavior encapsulated in a smaller number of boxes. Maybe even in one, like we work, like our human brain works itself, to have this small brain for the vehicle movement, for all these kind of reflexes, and the big brain for the higher level algorithms, but also then really reflexes on the lowest layer, which is the zone controller, or like you said, the door controller. Though we don't want to move all compute up, we want to have a well-layered compute system in the future in cars, where we can exchange software easily, where we can exchange components easily, where we break the monoliths. That's also important, because AUTOSAR in our world is a monolith. You can also only exchange the whole image And to break these monoliths in all areas of our software, to make it really into smaller, usable, maintainable elements, that's important. So this is the next big step in automotive compute in order to break the monoliths and to really bring us into a maintainable area of software development in the future.
James, as an analyst, I'm sure this is an area you look at. What do you see as the timeline for making this transition? As you look at the industry.
Well, as I've already said, automotive development can be highly iterative. Subtle changes upon subtle change, taking a number of years. And we have to consider, what are some of the big, new automaker requirements, consumer requirements, regulatory requirements that might start to drive, a bigger step change, and to cause OEMs to really start considering their compute architecture. And of course, one of those is electrification, and another big one is autonomous driving. And as automakers look to build 360-degree environment models, to add the necessary redundancy to meet the requirements in terms of reaction times, when they're starting to take on a lot of liability for automated functions, that drives a much faster pace of development. And as we've been talking about some of these innovations, and serverized compute, it's important to see that this isn't necessarily a brand new phenomenon. Rather, the automotive industry is starting to take on some of the best practices that have been honed in other, parallel electronics industries. And that means you can start to actually meet some of the consumer expectations for a connected device in terms of how fresh it feels, the ability to update, the ability to have it secure and to patch and meet any kind of cybersecurity requirements that come up without inconveniencing the user in a way that's very quick and responsive. And that starts to bring advantages for OEMs as well. What's good for the consumer being good for them, especially as we consider software updates, whether that's one-off sales or the kind of subscription type business models that we're seeing emerging. It allows the automotive industry to start to develop a revenue opportunity that will relate more and more to the install base of connected vehicles and less to whatever the new vehicle sales performance is this year. And obviously the automotive industry has had quite a challenging year because of extraneous factors that we all know. But soon enough, another bad year will come round, another macroeconomic shock. And so there's a real opportunity over the next few years for OEMs to start seeding the market, with vehicles that are updatable, upgradable, that can extract insights about its environment, that can then be monetized and give the automotive industry a revenue opportunity that's tied more and more to the install base.
This idea of having ongoing monetization from the vehicle, above and beyond the actual purchase price of the vehicle, I think is a fascinating one, and I think there's a lot of questions about how consumers are going to accept that. Vehicles, as we all know, if we've shopped for a vehicle in recent years, they're getting steadily more expensive. Are there opportunities, realistic opportunities to perhaps improve on the affordability of new vehicles and shift some of that revenue opportunity to the after sales, the ongoing, recurring revenues over the life of the vehicle? Is that something that's possible, or is this something that we're just going to be building on top of where we already are?
Well, sorry, James, you want to go?
Yeah, sure. I was going to say, when you consider a new generation of consumers, they're very accustomed to subscription-based ownership models of their media, and even of hardware like smartphones, etc. And so we see there have been a number of trials and also some commercial offerings of subscription ownership of the vehicles, and it's not too difficult to imagine that the experience that's built on top of it will also be more subscription based. And that also means for the used vehicle market, if I decide to pick up a used BMW in a few years' time, I may not necessarily be, tied to the decisions that were made by the first consumer at point of sale. But there's an opportunity for me to configure that, to meet my own requirements and my own expectations.
Yeah, I mean, these changes are gonna be introduced as the consumer behavior and consumer wishes are changing, right? I mean, it's we have to distinguish between the things like what Martin and myself discussed in the beginning, saying, okay, it's getting more and more a requirement for the car OEMs to design the cars in a different way inside, because otherwise the development cost is not handleable, or the qualification. What James was pointing to is, of course, the end user behavior, where my kids have a totally different pattern than me. I'm still okay having broadcast reception in my house, in my car, watching TV or listening to radio and so on. But for my kids, I mean, they are not grouping around the TV anymore in the evening when the evening news is coming, right? They run into the kitchen and tell our smart speaker to tell the news. Yeah. So that type of service behavior, moving in from a society that was used to have the status symbols with all equipment, to own them and to keep them, rather than to a full service society. That is happening, and that is what James was pointing towards. And of course, you have a higher resale value of your vehicle if you can also long-term provide this flexibility to the second and third user of the car. And therefore this naturally rolls back into the car OEM designs, that we have these service capabilities in. What we are seeing at the moment, an enormous hunger for connected gateways, for example. So cloud connections. We just recently had an announcement out with Amazon Web Services. AWS goes NXP gateway, secure connections to the cloud. And that is, of course, one of these steps that you're going to see much more often for the fleet management, life cycle management, but also for, let's say, the next generation of media broadcast into the vehicle.
Yeah, can fully support that. So we are moving into into the service-based world, more or less. We are moving away from these generations which had to own everything. So we owned a car, we owned music, so by buying CDs or LPs still, or cassette players. So we are not owning this anymore. So we are used to use these kind of services, and that's also the upcoming generations are really used to pay for services, even if they have it only short term for a while itself. So also there is not only a kind of a revenue for things you really steadily buy, but you use for a short time. If you go to a vacation, then you use special services to guide you, to give you some kind of a concierge service, and all these kind of services. They're all possible only by the data pipe into the car. So the connected car is the predecessor for all these kind of upcoming services. 20 years ago, we tried to offer these kind of streaming services like Spotify do today, but that was not the time. Nobody really wants to have it. So it was really a time where nobody was able to pay $10 a month for a service. To say, wow, that's not something which sells. Today, there are millions and millions of users of Spotify, and so the shops are empty with CD players and CDs itself, because we are all used to stream this and to use these kind of services. These like Spotify, Netflix, and others are providing us. So therefore, that's the chance also for the car OEMs to get, and also for other third parties to earn money inside the car or from the car itself, which then needs to be developed. And the predecessor for that one is the steady pipe into the car.
And I would even add to that and say it's getting more and more uncool to own, and it's getting cool to have a reduced and light footprint. That seems to be the fashion style of these days. Now, the car OEMs have to follow that trend if you want to produce a cool car, if you want to produce any cool, smart, connected device. It's about your reduced and flexible footprint. And that is, of course, like Martin said, nothing that was thinkable. 20 years ago, you only had been cool with 2 meters of CDs on the shelf. But today, of course, exactly the opposite is happening. And with that, the one who manages the services, the connectivity, the upgradability, the flexibility best, and the pay per service is not only opening new features, but is also the coolest car producer. And that is dramatically changing in the end consumer perception, in my opinion.
So between the data services coming from outside the vehicle, whether it's media streaming services or things like traffic information, map updates, and all the sensors in this layered software architecture that we have in the vehicle, how much data are we actually talking about moving around both within the vehicle and from the vehicle to the infrastructure?
Answer is that depends, Sam, because but that is also in a human being, right? You know, maybe this crazy calculations, how much data your eyes are generating every minute, and what with that is happening with these terabytes or petabytes of data in your brain. It's complete nonsense, because it's not only about big data, but already the retina of your eyes starts reducing. So once I recognize what is in the room where I'm also in, there is 4 people, it's Sam, James, Martin, and myself. And then I only get differential pictures into my brain. I'm talking to Sam, is Sam nodding or is Sam shaking the head? That's the only information, basically a 1-bit information, 0 or 1. He's agreeing or disagreeing with what I'm saying. And this filtering from big data to relevant data, that is what is also this stuff, of course, that we are working with the cars and the zonal architectures and the end node data. So the end nodes themselves are generating terabytes of data via 10 cameras, 20 radar sensors. I mean, just start calculating what is happening there in terms of raw data. Your car-to-car communication is ranging to the traffic lights in 400, 500 meters of range. That is all data that is relevant, but only in the very near field. And no one here in Hamburg is interested what is happening in Munich with the traffic lights. Totally irrelevant. You need to have it, but only on a very short range. And the relevant data is, hey, Lars, 50 kilometers ahead of you, how much traffic jam is there? But that's a few bytes. And the answer is therefore not terabytes, but look at on which layer, which relevant data is processed.
Yeah, so we're entering the gigabit area inside the car, so that we are counting the speed of the networks in gigabits per second. So the megabits, that's over, that's behind us. But also here, it's very important that we are not transporting all the raw data. Like I said, the filtering and the treatment of the data in the right place, that's the key later on in order to make compute affordable and reasonable. And also, but only a few of these data will be transferred to the outside of the vehicle, only if it's necessary. So there will be also new requirements to us that we even have to record a kind of a drive recorder from the European safety regulations itself. Also here we have to understand what needs to be recorded. That will not be the camera pictures of all cameras, and so not petabytes per second and into big data recorders. It's really to record also here only the really relevant data, which later on allows to understand what's happened the last 10 seconds before an accident happened or something like this. So it's all about the data management, the filtering, the right algorithms, and like I said before, a well-layered automotive architecture in order to have the right compute nodes and the right interfaces in the car.
I mean, what Martin just said, that is perfectly underlining why the hell do we need so much architecture discipline and so much cleanup activities and so much clarity in how we layer such a new, let's say, car architecture, how we build these rolling robots, and that we cannot just, let's say, glue another 2 or 3 boxes to the existing wiring harness and hope we can continue in that way. That is precisely, I mean, you can do that, but then you have to live with the consequence that it is difficult to qualify and that you're pumping loads of data. If you want to go to what we had just pitched, you have to re-architect completely, and you have to very nicely separate these layers from each other. And that's basically the next step that I foresee.
And possibly standardize the interfaces.
Yeah, of course, yeah.
Standardization will be key. So there are standardizations now about the way of software update and others. So we need better standards, more standards for these compute interfaces. Because nobody knows what underwear we have. It doesn't matter if we standardize all these kind of lower layers. Nobody has an advantage or disadvantage of that one. So the big advantage for us would be that we all have the same kind of application layer on top. If we would reach that time, that would really enable a lot of more innovation in cars than we have today. So in the moment, every OEM, every tier one has their own platforms. We need a standardization of platforms in the market in order to be faster and really to concentrate on the innovation of applications which are visible to the end customer, not to develop 1,000 versions of the lower layers of the interfaces to the hardware later on.
So the external pipe, it's interesting. A few years back, I heard Randall Stevenson, the former CEO of AT&T, in an interview. He was asked the question, "Why do we need 5G?" And this is as they were just starting to roll out some early 5G services. And the first thing he said was, for autonomous vehicles, these vehicles require so much computing power on board. With 5G, with the low latency and the huge bandwidth, we'll be able to move that computing out of the vehicle into the cloud, or at least to the edge of the network. Is that something that you see as reasonable? I mean, I think I know the answer to this, but do you see that as something, eventually something that is realistic, that we can actually move a lot of this processing out of the vehicle to at least the edge of the network?
Again, yes and no. So if the idea is that the car is driving, all the sensor data is pumped into the cloud, and the car gets the steering advice back from the cloud, forget it. Will not happen, because the car has to drive also when network is not available. Otherwise, good luck. So the vehicles, these rolling edge devices, have to be completely autonomous by themselves. Now, nevertheless, what is needed, what might help a lot, is if our cars, when they have done their driving day and they are in my garage, or maybe also while they are driving, upload non-time critical data to the cloud, and they jointly learn in the cloud. So in other words, Sam's car, James' car, Martin's car, Lars's car, we all drive maybe in the same city. In the evening, we all park our cars. The cars send their experiences to the cloud, so to say, like humans are dreaming and hardening their experiences of the day in the dreaming. My car starts dreaming because experiences in the cloud is combined, is learned with a lot of others, sent back in the morning. So my car has new experience and is learning while it's dreaming. Yeah, and for that, 5G or Wi-Fi 6 broadband data connections make sense. Of course, also for infotainment streaming, where the functional safety is not that critical. But for everything that is functional safety critical, complete nonsense to assume that wireless connection would take over that job.
One of the interesting areas that I've seen recently, for automated vehicles is around the maps. Maps are becoming far more complex. When we first started putting navigation systems in cars, basically all we had was street level maps. That said, here's the names of the streets, here's where they intersect, here's the layout, and your position plotted on that map from a GPS receiver. But now, as we get into these more sophisticated driver assist and automation features, we're getting multi-layered maps that include the topography of the road, getting real-time information about friction conditions on the road, that's collected from other vehicles and aggregated. How much data do you see that sort of application needing just to keep the maps fresh and to provide all these rich data layers on top of the street level maps?
Might not be necessary really to store the high definition map for the whole world on the car. So if you have a reliable network, you download it in the moment you are entering the next big tile itself. So you can really get this, especially in the cities, we will have these high performance networks with the high frequency 28, 39 gigahertz networks, which are very small cells with an enormous capacity. And you can really download the high definition map of the next area driving in. So you don't have to store it in cars, because that would be petabyte. And we don't want to have these big drives even in the car. And the information is all the next day, because there might be a road construction area which comes in the morning, and you have to have these data. So that's something which is very important here for the autonomous cars, that we download really recent information just the moment you will use this. But maybe coming back also a little bit to the automation, it is also possible to remote control the cars in these high performance cells. That your car is driving, that the city is driving your car, or that Microsoft or Amazon is driving your car if you're entering that zone. Because the problem I see also to enter this time of autonomous cars is that if you have 5% autonomous cars and 95% drivers around, which really can shock these cars and can do some really nice little things with these kind of cars which are driving autonomously, that might be a threat also for the guys inside these cars, because it's an autonomous car, it will break. So or these digital stone throwers, they say, okay, stepping on the street just in front of the car will break itself. That's all. It's a threat for the robot taxis. So there are two ways: whether the car is really driving on itself, and all the cars around are driving in this moment autonomously, and that's more easy, because then these cars will not do something stupid to the others itself, because this is a community and they talk to each other, so they respect each other. But especially in some societies, I see a very interesting development if you have these autonomous cars mixed with non-autonomous cars, with driving egoists, I guess. That will be a very interesting time. But let's see. So maybe you can really also automate the car from the network, from the edge itself, because you only have to drive the car in that cell, and you pass the car into the next cell, and the environment can drive the car. And that even level 2 cars, which we have in the next 20 years, are all able to do this and can be automated. So then that's a predecessor in order to enter this kind of zone in an inner city, that your car is automatable. All the other cars have to be stopped there. So that's also a kind of a solution you can do by these kind of networks, by the automated and by the connected car, that you automate the car from the outside. It's another option for this kind of the connected car of the future, that you're not driving your car, even if you are still a driver in the car, that you have to take the wheels, the hands off the wheel itself, and that the car will be automated. That's maybe even more simple scenario than if all the cars have to be automated and drive themselves, if the equipment drives the cars, if the city drives the cars. That's maybe also a vision which is very interesting for the future.
Yeah, definitely, Martin. What I also had seen in France, they had studies, where, as you said, like kids stepping in front of an autonomous vehicle, right? The vehicle brakes, gets stuck, tries to drive around the obstacle, and the kids just were jumping one step left, one step right, and the car was completely blocked. I mean, that is, of course, a thing that will happen the moment where level 5 type of, so fully autonomous cars, no driver in, are on the roads. I'm still thinking of a Hamburg or Munich cab driver. I mean, if teenagers do this in front of that cab driver, I mean, the guy will be out of that car and chase the youngsters in a second, right? So what you might need to have is, you might to have sort of a like a drone mission control center, where operators can switch themselves into the vehicle, like Martin said, and can start driving the vehicle from the outside. Maybe not even the entire traffic stream, like Martin just pitched it, but in the single cases, being able to bring cars out of crazy situations where they are stuck in a deadlock. These type of things, of course, are all needed and are all happening. For that, you need, of course, the high bandwidth, low latency, and very robust connectivity. You need all the functional safety architecture sensing around it anyhow, not to create any damages. But we will see these type of use cases merging, and ideally maybe ending in completely city-driven fleets. Absolutely.
Mm-hmm. Yeah. And that kind of teleoperation, just to say that kind of teleoperation will be very important in the early years of level 5 rollout, when consumers are still getting used to using these kind of vehicles. You can imagine a kind of nightmare scenario whereby a consumer who isn't quite so sure gets in a robo-taxi for the first time, and then halfway through the robo-taxi encounters a scenario that it can't accommodate for and says, right, get out. That obviously is not acceptable from, whatever kind of fleet operator is putting their brand to that kind of, operation. So yeah, remote operation, teleoperation, for that you do need, the bandwidth and the latency, and more importantly, to what Martin said earlier, the trust that you can have in the 5G connection.
James, following up on that, James, are the networks that are being built robust enough, and do they have enough throughput to actually achieve this sort of city-driven fleet, at least within limited zones, within a limited ODD? Do you see the networks getting to be sufficiently robust to do something like that?
Yeah, I certainly think so. As you said before, when you quoted from AT&T, they recognize how important this use case is in terms of delivering ROI for 5G. Don't get me wrong, it's still kind of a longer term ambition. And I've yet to come across an AV software developer who says, yeah, we build our architecture around the need for 5G, because they want the vehicle to be as autonomous and self-contained as possible. Not only from a safety and actuation and collision avoidance point of view, but also to the maximum possible extent navigation.
And it would for sure not be that there is a complete remote control of the car as it drives, and no safety systems around it. I think more of a thing like saying, okay, you are on the middle, left or right lane, driving 40 kilometers an hour, slow down in front of the traffic light and so on. So advice to the fleet, but the vehicle stays center lane itself, it stays away from other obstacles and so on. So I mean, that is definitely stuff that the vehicle itself has to manage. That will never be handed from an operator into the vehicle over a cellular network, because that would be a functional safety concern. But it's also not needed, because this is what the cars today already can perfectly do, and only if they get stuck, then the operator needs to look around the context and say, okay, in this context, do this and that move. Yeah, but give the advice like a driving teacher on the passenger seat. Yeah,
yeah, but the networks. So if you really follow the plan of 5G, the ultra reliable network, which comes in the next big release here, is a big one. So you will get a guarantee about the network performance of the quality of service, and this even more you can really expect from your DSL network at home. So ping times of 1-2 milliseconds, that's a lot faster than what we experience in our homes itself, where we have 15 to 20 milliseconds. So this enables features which are currently not possible because of the unreliable pipe. So the reliable network and also the high-speed networks, which we'll see in cities, will allow us to do a lot more than it is possible today. So 5G is a predecessor for many, many things which we can even not envision today. So this will develop over time. Up to now, there is not even a single cell for 28 gigahertz. But I think we did research on wireless LANs in this frequency area. It's a very reliable network, and also with a very low error rate in the field, in the zone itself, in the cell. And so that, like I said, these to control cars from the equipment is currently not even envisioned, because the networks are not there. But if the networks are there, then we can have complete different applications possible in these kind of cities. Not everywhere, not on the lower populated areas, but especially in cities. We can do a lot more than we envision today.
and that will even grow for 6G if you're just looking at the combination capabilities, 100 gigahertz sensing plus communication and connectivity. I mean, that would be then the just beyond what you just said, Martin, just the next step of evolution even. So yeah, a lot more possible then.
One of the really valuable elements of having this external connectivity, particularly V2X and V2I connectivity, is to allow the vehicle to anticipate in ways that a human driver can't. Even with all these sensors we have on the vehicle, they're limited to line of sight. Cameras or LiDAR or radar can't see through the truck or bus that's in front of you. But with connectivity, you're able to pull in all this other information beyond line of sight and anticipate and hopefully make smarter decisions before you get to a situation where where you might be in an emergency scenario.
Your car gets telepathic capabilities, yeah, absolutely, superpowers.
Yeah. It can look behind the corner
Yeah.
and can look above the hill. So that's really important. So I guess we used all these kind of technologies to lower the risk in cars, which are possible with these kind of ADAS systems today. So the next big step for us is also the community of cars then to warn each other and to communicate even if they're not in line of sight. So because you can only prevent an accident what you can see in front of you, but not what you cannot see in front of you. And V2X is a very important element to also to warn each other, then also for emergency vehicles, for all these kinds of use cases. So V2X is a big enabler then for more road safety in the future.
So with all this, there's one topic that we kind of briefly touched on a little bit earlier, but that's the whole premise of trust and security and resilience in these systems. What do you see as the elements of trust, and how do we enhance trust for the users of vehicles going forward as we add these potential new attack surfaces through all this connectivity?
Yeah, so constant software update is important. So because that's also what the only element. So nothing is secure over time forever. That's something which is even the wireless LAN standards and the safety standards. They have to evolve over time. Also, the pipe into the car is not something we can engineer today and say that's the one which we will use for the next 20 years. Because the computers will be more and more powerful in order to crack these kind of encryptions which we are using in order to secure the pipe. But the reliable pipe is the absolute predecessor for any kind of these automated use cases, for software update, for all of these ones. But what I understand here is this is a kind of an evolution which then also will lead into updates of the standards of the pipe, that we always use the best and available pipe standard for the private pipe for each car into the cloud, into the edge.
Yeah, I mean that's what we are doing in other industries already since quite a while. So with our experience in banking, in e-government, in secure connections to the cloud. I mean for industrial and so on. That is of course a lot of exactly that work what Martin just had described. For trusting your device, I mean, there's only two vectors. The one is security, so hacking robustness, and the other one is functional safety. And for both, you need to have the right architectures in place. You have to have the right risk assessments process-wise. We call it ISO 26262 in the functional safety area. Same mechanisms are happening for the security architectures of the vehicle. And the more you're compartmentalized and the more, let's say, discipline in your architecture you have, the more clear you can be on your firewalling, and the better it gets in determining so what is your door lock, what is your strong door, what is your steel bars in front of your windows, and so on. So basically just to get the architecture very robust, very clear and trustworthy, and that's it basically.
All right, so as we run out of time, I'd like each of you to share any final thoughts that you might have around connected vehicles and the potential benefits.
Yeah, for me, the connected car is the predecessor for the digital life of cars. And for me, this is absolutely mandatory to connect each and every car to the edge, to the cloud system itself, because it unlocks a new ecosystem for the whole world. So it's not only the connection to the OEMs, it's also to many third parties for new ecosystems which are currently in development and currently in vision. But to get a reliable pipe in each and every car is mandatory for the digital car for the future.
I would say, the connected car is moving in a direction not only in terms of the data that is transmitted to the vehicle, but also what can be aggregated from the vehicle. And we obviously connect data from a lot of different connected end devices, but in the IoT context, the connected car is quite unique in the sense of how mobile it is, of the richness and variety of sensors that are being equipped to vehicles, and also in this evolution that we've been talking about today, in having the necessary architecture at the edge to allow for insights and understanding of the world to be extracted at a massive scale, and then for that to be monetized.
Yeah, I mean, for me, the connected car is basically a next evolutionary step in vehicle architectures, requires, has much more compute performance capabilities at this rolling edge node, is a rolling sensor platform, as James said, in itself. And with that, it's the next evolution of vehicles. So it sounds very futuristic what we have discussed, but it will not be that now the entire auto industry is going to wiped out and only the robot builders who are gluing wheels to their robots are the next generation. That's not happening. This is not what I'm seeing in the industry. Nevertheless, getting these new capabilities into the industry is a key activity of the next 3, 4, 5 years, and the capabilities, of course, of this rolling cabin will dramatically change.
All right, and with that, we'll wrap it up. And I want to thank the panel: James Hodgson, Principal Analyst at ABI Research; Martin Bornemann, Director of Systems at Aptiv Mobility Architecture Group; and Lars Reger, the CTO of NXP.
Thank you.